Boy, I got a lot of wires on the circuit board now. Look at all this. This is by far the most complicated circuit that I've had to do so far. But it's mostly working. Um, I've got the microcontroller asleep right now. It's drawing 5.8 microamps still, so that's cool. And if I put it on the milliamp range and I hit this button, it'll wake up and then it will go and just flash the RGB LED segments that are in this knob here, and it will go through all the segments of the 7-segment display, and then it's even talking to this radio module that's right here. I can show you that real quick. When it wakes up, what it'll do is it'll read the config register. There's several different registers that are inside of that little that little integrated circuit that they got on there. So it reads the config register, then it writes a change to it, and then it rereads the config register, and it's actually able to make the change on it. So that just kind of was my proof of concept that I was able to get all the SPI communication working between these two devices, the microcontroller, and then also make it so that I can still use a programmer, so I can plug in this programmer and I can put a bootloader on the microcontroller with all this stuff still plugged in. And yeah, that's working out pretty well. So one of the improvements that I've made to the circuit from last time was before I was having the serial converter, which is that little chip right there that turns the USB into serial. The way that I was making it go into a low power state was bringing its reset pin low when USB 5 volts was not being applied. And I had a transistor arrangement to do that. Well, I realized later that I could just get rid of the transistor and I would have a voltage divider there, and it would turn the 5 volts into 2.5 volts. And that's enough to bring the circuit out, or to bring the chip out of reset. So I just got rid of the transistor and have a voltage divider there, and that works just fine. So one less part, so that's cool. The schematic has gotten a lot of work on it too. Here's the voltage divider that I put on for the reset. So I've got all the different parts here on the schematic, and I think it's mostly done. I just have one little problem with my circuit that I'll show you at the end. I need help with it. Maybe I should have done it in the beginning, because I make too long of videos. But I'll show you anyways the little trick that I had to do to make it so that the programmer, which plugs into this plug here, can still program this chip, but the shift register and the radio can still be plugged into connected to the chip as well. The little trick that I found worked was on the SPI pins, the master out slave in, the master in slave out, and the S clock. If I put the S clock directly to the programming header, and then I create an S clock 2 with a 1K resistor, and I use that connection for the shift register, there's S clock 2, and then the radio module, there's S clock 2. That's all it takes. That allows me to do the programming of microcontroller with a normal programmer. So I read online that you can isolate all your SPI devices by doing that, putting a little resistor on them. And I just this process of elimination, trying different combinations, what would work and what wouldn't. And I found that I could just put it on the S clock 2 or the S clock pin, and that worked just fine. So that was cool. All right, so the problem that I'm having, that I'm hoping somebody will be able to help me with, is with the P-channel MOSFET. So I'm using the P-channel MOSFET as a high side switch, so I can just normally the base of the gate of the MOSFET is pulled up to 3.3 volts, and that turns it off, so it's switched off, and so that's how this is all set up right now. This thing is currently switched off, and this this rail here is currently sitting at 0 volts because it's off. But if I go and I hit this to wake it up, you'll see the rail goes up, and it goes through the little test that I have it do, and then it switches right back off again, back down to 0 volts. So that's working okay, but it took me a long time to get it to that point, because I discovered that if there's any kind of capacitance on this rail, this is a 10 microfarad capacitor. If I put a capacitor on the 3.3 volts down to ground, and I hit the button, it won't work anymore. And actually the microcontroller is stuck. It's resetting over and over and over again. It can't wake up. And the voltage never goes above 3 volts, and it just gets stuck. And if I remove the capacitor, then it does turn all the way on and go through the little test and then go back to sleep. So I can't put any capacitance on this rail for some reason. And what really made this tricky was when I was doing my testing, I was using this module here, which I happened to just put a capacitor on the VCC and ground pins on it. This is just something that was recommended, I saw online. When you start transmitting, this chip can draw some juice, so people do that to help out, making it more consistent. And so I had this plugged in, unfortunately. I've only got one with one of these capacitors on it, and it just happened to be the one that I had plugged in here. And it was just locked up. You know, it hit the button, it was just locked up. If I disconnected the power to this, then it would work just fine. And eventually, I finally figured out that it was the little capacitor that was on there that did it. And so, yeah, I'm kind of stuck. I don't know what to do. I changed the circuit. Instead of using this kind of layout to turn the P-channel MOSFET on, I went with a NPN transistor to ground the base to try to get it to turn on. And that didn't help, and that's actually what I've got plugged in right now. I'm using an NPN transistor to ground the base of my MOSFET. This is the MOSFET that I've got. It has a gate source voltage of negative 0.55, and so I've got, you know, on the gate, it's normally pulled up with this 10K resistor up to 3.3 volts. That rail back there is at 3.3 volts. And, you know, I'm using this yellow wire here to bring it down to 0 volts when I want to turn it on. And it's, so I'm putting, you know, minus 3.3 volts on the gate. And if there's just that capacitor on there, it just won't work. And I don't know what to do. The radio module does, you know, you don't have to have that capacitor on there. It does seem to work okay. And the shift register doesn't, you know, it doesn't seem to be exhibiting any problems not having a decoupling capacitor on its VCC pin. So maybe I can get away with not having any capacitance on this 3.3 volt switched rail. But I really would kind of like to be able to do it if I wanted to, and plus for future projects, I thought this P-channel MOSFET doing high side switches would be just great. But I've got this problem. If you have any suggestions, any thoughts, please let me know, because I am scratching my head over this. But yeah, besides that, a lot of progress is being made, and I've even started the board layout. This is, you know, really, I just got started doing this the other day. I'm just trying to group together the like functionality things. So this is like the serial converter and all the resistors and capacitors it needs, and microcontroller. So I'm just trying to group things together and figure out how I'm going to position it and figure out how big my board is going to be and stuff like that. So just kind of getting started on that. So yeah, making a lot of progress. Hey, I finally got it to work. The old P-channel MOSFET gate threshold voltage. In my brain, when I saw the minimum, typical, and maximum figures, for some reason I thought, well, if I put minus 3.3 volts on it, then it'll even be more on. I was a moron. It was that doesn't work at all. You have to stay within that range they give you. So so once I realized that, I've got my multimeter here showing the voltage that's on the rail. So this is what the P-channel MOSFET is doing. It's got pretty much turned off here, and that's just the power draw from the battery. If I come here and I hit the button, you'll see that goes up to, let's see, it went up to 3.26, and then it slowly goes back down in voltage because I've got right now a lot of capacitance on here. I've been testing it. I got a 10 microfarad capacitor stuck in here, and then I've also got the little module with the 10 microfarad ceramic capacitor on there. And so it slowly goes down in voltage as the capacitors are discharged, and I can just touch that to the ground to drain it real quickly. But yeah, that now it works okay. It turns all the way on and turns all the way off appropriately because I'm applying the right voltage to the gate. So what I was doing before here was, so the gate was here and I got 3.3 volts there. I was basically going to minus 3.3 volts according to how they list it out here, and because this was at 0 volts and that's at 3.3, so that was too much. I need to stay between 2.1 volts and 2.9 volts because that's their range that they give you here. And so I just created a resistor divider. I used some 10Ks. I tried a bunch of different resistors, but like I tried these 100Ks and I tried some 10 mega ohm ones, but they didn't work. They weren't turning the MOSFET all the way on. But these 10Ks worked out okay. I put 2 of them in parallel to create a 5K equivalent one, and then I got a 10K on that side. And that's how I'm getting 2.2 volts to the gate. And that's within the range here, and it works just fine now. So that was the trick. Now the circuit is still not drawing any power hardly at all when it's asleep, 5.8 microamps. So that makes sense because when the microcontroller is off, I've got the pin here that controls the P-channel MOSFET set to be an input, so it's not even part of the circuit basically. So the gate is just pulled up to 3.3 volts when it's asleep. But when it's awake and we've got the 3.3 volt bus turned on, there's this resistor divider set up, so there will be current that can flow through here. I haven't calculated out what it's going to be, but it might be significant. So it would be better to have a P-channel MOSFET that you could have like maybe minus 5 volts on for the maximum, because then having minus 3.3 volts would fit within that range just fine. So maybe I'll look into buying a different P-channel MOSFET now that I know what to look for a little bit more. But yeah, this is great.